Alright, so here we have the density equation. Rho, the symbol that kind of looks like a P is actually rho, the Greek letter rho, is equal to mass divided by volume. The capital V here is volume. Let's go over the units of each of these. So rho, the density, is typically in grams per cubic centimeter. So centimeter to the third. Okay, so of course what that would imply is that the mass has to be in grams and that the volume V, it's capital V, must be in centimeters cubed. Alright, so those are the units. Let's do an example. So, alright, so here's our example. We're going to use a mass of 2.4 kilograms and a density of 3.3 grams per cubic centimeter. And so what we're looking for is what the volume is. What is the volume? Alright, so let's of course take a look here. The mass is 2.4 kilograms, and as we said a few moments ago, it has to be in grams. So we'll start with a simple conversion. Let's do that right here. So our mass, which is equal to 2.4 kilograms. And so we're going to do the same thing that we've done in a previous video. We'll just take a look here, and kilo, which is right here, it literally means times 10 to the third. Okay, so we're going to just replace the K with times 10 to the third. Alright, so let's do that. So this is 2.4 times 10 to the third grams. Alright, and so that's our conversion. If you wanted to, of course, since it's the decimal point is moved 3 places to the right this time. Let's see. So if you just you can leave it like that, or you could have it as 2400. Right, because so we've moved the decimal point 3 places, and so it's 2400 grams. Alright, so now let's get to the business of solving this, and we'll start with the equation. The density, rho, is equal to the mass, which we now have in the proper units, divided by the volume. So this is a typical thing that we're going to do throughout the semester. We have an equation, some relationship between variables, and we have to solve this. Of course, this is algebra. This is the algebra that we learned in high school, and we're just going to apply that here. So let's see what we need to do. We need to isolate the v, so get the v by itself. And if you remember, one of the things that we can do is what the general thing that they talk about in math classes when you're doing algebra is that what you do to one side of the equation you have to do to the other. And so we're going to multiply both sides by volume. Now, why would I choose to do that? Because volume here, this volume is in the denominator, and so we got to get rid of it. So those two volumes cancel. Now the equation, we can rewrite the equation. The whole thing is rewritten as the volume times the density is equal to the mass. Alright, so but we're not done here. We still have to get rid of this density, right? It's got to be V equals something. And so since the density rho is in the numerator, I'm going to divide both sides. Remember, what I do to one side I have to do to the other. I'm going to divide both sides by rho. of course, I can cancel this row on this side. And now let's clean up the equation. It becomes this: the volume is equal to the mass in grams divided by the density in grams per cubic centimeter. All right, and so let's just put in our numbers. You can either put 2.4 times 10 to the third or 2400. I'm just going to put the 2400. 2400 grams divided by, and I believe our density was 3.3 grams per cubic centimeter. So 3.3 grams per cubic centimeter. And let's take a look at the units for a second. This grams right here will cancel this grams. And when you have, notice this, the centimeters, it's 1 over centimeters cubed, so that's going to cause the centimeters cubed to come up to the numerator. All right, so which is exactly what the units of volume should be, right? The units of volume should be cubic centimeters. So it's really just a matter of dividing, taking 2400 divided by 3.3, which I've already done on my calculator. It turns out that this is 727.3. Let's just round it right there, 0.3. And since, as I said, you have the centimeters cubed down here, that comes up to the numerator, so this becomes centimeters cubed. Here, let's make that a full C. All right, and so this is our answer, 727.3 cubic centimeters. All right, and just make sure that you can do that in your calculator as well.